Hello, welcome. Today let's try to solve another Leetcode problem, 646, maximum length of a pair chain. So we are giving a pair of, we are giving pairs inside the pairs array, like 1, 2, 2, 3, and 3, 4. We just need to find the longest chain. So what do I mean by longest chain is like 1 to 2 and 3 to 4. So this 2 cannot be equal to this number 3. It must be, so this number, it means the next start number must be bigger than the previous end number. We just need to find the longest. So for example, 1, 2, 4, 5, and 7, 8. It's the longest, it's 3. As you can see, it is exactly the same as the longest increasing subsequence problem. You just need to find the longest increasing subsequence. Yeah, just here the difference is that there are two numbers. We just need to compare if there are no overlapping. Yeah, if it is like that, for the intervals problem, normally we're gonna sort. And here also the same. After sorting, it's the greedy idea. And then it will be easier for us to compare to check if there are overlapping or not. For this example, 2 and 2, this is overlapping because according to the problem. So this left and right. So the left should less than the right. So this means this 2 should less than this 2. Otherwise, we're gonna not count. Yeah. And for this problem, yeah, it is the longest increasing problem. Now let's start solve it in the longest increasing subsequence template. We just need to sort the pairs first. Let's sort the pairs. So for the pairs sort, we are sorting at the 0 index. It means it's easier for us to check if there is overlapping or not. After that, we're going to prepare an n variable, is the length of the pairs. Now we are going to loop through the array. And for the result, I'm going to, I don't need to get a result because I will prepare a DP array. So for the DP array, because even there's still one pair, so the length will still be 1. Even there's always be overlapping, the longest is 1, I still have a 1. So this is why for DP is 1 times n. Now I can loop through the DP array. So for I in range 1 to n, and for j in range. Why? Because there are basically two ways. One way is O(n) square. Let's check the value of n. So n is 1000. It means even we use n square, we can pass for this medium problem. If it is a hard problem, maybe they let us, if they are giving an n of 10 to the power of 5, we cannot use this method. We have to use greedy. We have to use n log n time to finish it. Yeah, I will talk about that later. But for this problem, for simplicity, I will just keep it O(n) square. Now, for the j should be to I. Yeah, this is basically the template for the longest increasing subsequence problem. Now, let's just check. So the check is, what is the previous value? So the current value is I. So the previous value is j. We just need to check my current start is more than the previous add value. So the current start is yes. So the current start is nums I with 0, and the previous end value is just nums j, because here I will compare one by one. For example, this is my index with 2, my DP index is 2. At this position, I'm going to check one by one before it. So this is the similar to the longest increasing subsequence problem. Now, if it is okay, we just need to update the DP. So for the DP, I should be the maximum of DPI with DP z plus 1. Now, we just need to return the maximum of dp. You can see that it is exactly the same as longest increasing subsequence problem. Only the difference is for that condition, we need to have a tag. For the longest increasing subsequence, it's also the same. But here, we need to tag overlap or not. Also, we need to sort the pairs array first. Otherwise, we cannot tag that so easily. Now let me just run it to check if it really works. Nums, oh, it's not nums, it's pairs. Yeah, now let me copy the pairs. Let's run again to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. Thank you for watching. See you next time.